Hello, this is Peter Minnett giving this presentation with my co-authors Jorge Vazquez and Ed Armstrong from JPL. Of course, there are many others at Rasmus, at NASA Goddard and at JPL involved in the production of sea surface temperature fields from MODIS. As we know, MODIS is a 36-channel visible and infrared imaging radiometer that flies on the NASA satellites Terra and Aqua of the Earth Observing System. Both have now been in orbit for over 20 years and produced data for nearly all of that time. And they were, of course, planned for much shorter lifetimes. There are two sets of infrared channels for the generation of SSTs on MODIS. The regular split window NL-SST atmospheric correction algorithm uses measurements at about 11 and 12 microns wavelength. MODIS also includes a pair of channels in the mid-infrared atmospheric transmission window with central wavelengths at about 3.95 and 4.05 microns. But these can, of course, only be used at night because of solar contamination during the day. Their retrievals are designated SST4. The table on the right shows an assessment of accuracy for the best quality retrievals, QL equals 0, at night, derived from comparisons with buoys and ship radiometers. The SST4 retrievals are significantly better than the thermal infrared NL-SST retrievals. Here we see time series in monthly box whisker plots of the NL-SST on the left and SST4 in the center of the MODIS skin SST retrievals compared to buoys or buoys subsurface temperatures for the entire Terra MODIS mission. Each row consists of a range of latitudes starting at the bottom with south of 40 degrees south, then 20 to 40 degrees south, 20 degrees south to the equator, equator to 20 degrees north, and so on. The upper row is north of 60 degrees north. The data are very, very consistent over the 20 years of the mission. The scatter in the SST4 is noticeably smaller than for the NL-SST. The right-hand panel shows the box whisker plots for the SST4 retrieval discrepancies as a function of satellite zenith angle. There is a growth in the uncertainty across the scan with increasing scan angle, but the median value is essentially constant. The red line is positioned at minus 0.17 Kelvin, which is taken as the average thermal skin effect. Both Terra and Aqua were placed into maintained orbits, meaning that the ground tracks that repeat after 3 days are all within 1 kilometer. This required frequent orbit adjustments, but the fuel for such maneuvers has been expended and the orbits have begun to drift. Terra is moving earlier in the day and Aqua later in the day. The plots show the equator crossing times of the drifting orbits, left being Terra and right being Aqua. They are expected to reach a point where continued maintenance of the scientific mission of the instruments becomes an issue, and that will be sometime in 2026 for both satellites. This is largely determined by the incidence angle of the solar radiation on the solar panels to produce enough power. And this brings us to the concern of how to continue the long time series of skin SSTs derived from MODIS. For Aqua, the continuity missions are clear. It's the VIIRS on the SUMI NPP satellite and on the operational NOAA 20 and 21 satellites. These have approximately the same 1330 equator crossing time, but they're in a higher altitude, so that there isn't an exact correspondence with the MODIS sampling. But the wide swath gives global coverage each day. The infrared channels on VIIRS are a subset of those on MODIS, meaning that there is no possibility of a nighttime SST4, but a 3-channel algorithm using 11 and 12 and 3.7 micron measurements appears to function very well. The regular split window algorithm for day and night is comparable to that of MODIS in its accuracy. Progress is already being made at Goddard at the OB-DAC and at the PODAC at JPL to produce VIIRS SSTs. The satellite series will continue with JPSS-3 and JPSS-4, which will become NOAA 22 and NOAA 23, carrying on the time series of skin SST measurements well beyond 2039. The question of a successor instrument for the Terra mission is not so straightforward, as there is no current or planned US satellites flying in the 1030 equator crossing time orbit. There are, however, 3 groups of European satellites in morning orbits, which we anticipate could provide data continuity for the Terra mission. And those are the AVHRR3 on METOP B and METOP C, with a 930 equator crossing time. SLSTRs on the Sentinel-3 series, of which there are 2 in orbit and 2 further planned, have a 10 AM equator crossing time, but have somewhat narrower swaths. In the longer term, the best candidate appears to be the MET image, which will fly on the 2nd generation of METOP satellites of EUMETSAT, and the first is expected to be launched early in 2025. So the best option, if MODIS on Terra were to fail now, would be the SLSTRs, and in the future it would be MET image. So, why are we concerned about the continuation of the MODIS SST time series? There are many reasons, but one of the most pressing is that MODIS SSTs are the basis of the MUR, which is, as you know, the multi-scale ultra-high resolution SST dataset. This is produced at NASA's PODAC at JPL. Recently, the generation of MUR has been modified to ingest MODIS SSTs and other data from the AWS cloud. MUR has many users, about 2,500 in a recent year. And MUR is the basis of many research projects and is used for analyses produced operationally. It is the default layer in the State of the Ocean Worldview image browser, and it is also a key layer of the recently released NASA Earth Information Center, which is a public outreach facility at NASA headquarters in Washington, D.C. Future plans for MUR generation include incorporating VIIRS data from SUMI NPP and from NOAA 20, and having the processing take place in the cloud. Both goals are achievable, but they require significant investment in effort and, of course, carry some risk. To summarize, both MODISes have produced over 2 decades of high-quality, high-resolution skin SSTs, which are widely used in the community, including in the generation of MUR. This is the most downloaded SST dataset from the PODAC. There is no avoiding the fact that the lifetimes of the MODIS on both Terra and Aqua will come to an end in the next couple of years. The best option for continuing the data from Aqua MODIS is straightforward, using vias. Less straightforward is the choice for the Terra MODIS. And it is also very likely that MUR will be extended well into the future using vias data. Thank you for your attention.